The second question we want to take in our topic, graphical representations on proportion, is this question. The former graph we plotted was a graph of a direct proportion. This I will use to explain the graph of an inverse proportion. The question says, a vehicle traveled a distance of 80 kilometers. Question number A. In a table, find its speed after 32, 16, 18, 4 and 2 hours. Question number B says, draw the graph of speed against time. C said, use the graph to find the speed if the time is 5 hours, and also find the time if the speed is 25 kilometers per hour. Now, first of all, they said that the vehicle traveled a distance of 80 kilometers. In a table, find its speed after this line of time. We will start by saying that speed is calculated mathematically from distance covered divided by time taken to cover the distance. This is the formula for finding speed in science, in mathematics. Now, we are to calculate speed because already we have been given the distance and we have been given series of time. So we are going to calculate the speed that are related to 80 kilometers and 32, 16, 18, 4 and 2 hours. When we do, after we have finished calculating it, we now put it into a table. It will now form our table of values, which we are now going to use to plot the graph that question number B is asking for, and answer the question that question number C is asking for. So speed. The speed when the time is 25. Speed for 32. Speed for 32 hours time will give us S. Let's S represent speed. Is equal to distance, which is 80, all over time, which is 32. Let's use calculator. 80 divided by 32 is 2.5. So we have 2.5 kilometers per hour. The next one is the speed when the time is 16 hours. Speed for 16 hours time. S is equal to distance over time. The distance is 80. So use 16 to divide 80. You are going to have 80 divided by 16 is 5. Is 8 hours. So time for 8 hours S is equal to 80 kilometers, which is the distance, divided by 8. This one we don't need calculator. 80 divided by 8 will give you 10 kilometers per hour. This is kilometers per hour because it is speed. The next is when the time is 4 hours. So we have during 4 hours time, our speed is going to be 80 divided by 4. And if you use 80, 4 to divide 80, you have 20. So we have 20 kilometers per hour. The last but not the least is when the time is 2 hours. So the speed for 2 hours time It's going to give us x is equal to 80 divided by 2. And 80 divided by 2 will give you 40 kilometers per hour. Now we are going to use these values that we have calculated now to form our table of values. And I'm going to form the table of values here. It's going to be time and speed. So let's make it a value. Let's manage this space here. Okay. The first place, when the time was 32 hours. 32 hours. We calculated the speed to be 2.5. So we have 2.5 kilometers per hour. Then the next, when the time was 16. When the time was 16, we calculated that the speed was 5 kilometers per hour. The next is when the time was 8 hours. We calculated speed to be 10 kilometers per hour. The next was when the time was 4 hours. We calculated speed to be 20 kilometers per hour. The last but not the least, when the time was 2 hours. 2 hours, we calculated the speed to be 40 kilometers per hour. So this is our table of value. It will be with this table of value that we are going to plot our graph and answer our questions. So we are going to paste our graph paper again on the whiteboard and come close to draw the graph. You can see the graph paper pasted on the whiteboard. Let me bring it close. It's coming close. Yes, it's coming close. Okay, this is the graph paper. If you look very, very close or very, very carefully, you will discover that the left hand side of the graph paper has a ruler attached to it. I am going to use that ruler to teach you how to choose scale before plotting a graph. Then if you look at the right side of the graph paper, that is the exercise book side, you are going to find out that that place now, I have copied the table of value you have here. This table of value that we constructed a few minutes ago. This table of value now, I have copied it into the right side of the graph paper. This place now. That is exactly what I have in this place. Okay, you can see it clear now. That is the table of value that said time in hours: 32, 16, 8, 4, and 2. Then speed 2.5, 5, 10, 20, and 40. I did it so that it will be easy for us to be taking our values that we are going to plot on this graph side of our graph paper, so that when we take the camera close, we'll be able to be assessing the things we are plotting easier and better. Another thing I have on the graph side, on the exercise side of our graph book, is the questions. These questions that we have here that says, let me take it back so that you see the questions clear. Okay, the question is going back. Going back. Okay. This question that says A, in the table find its speed after 32, 16, 8, 4 and 2 hours. That we have done in that table of value there. So that table of value have answered question number 1. Sorry, question number A. Then question number B. Draw the graph of speed against time and use the graph to find the speed if the time is 5 hours, and also find the time if the speed is 25 kilometers per hour. I have copied the B and C part of the question on the exercise book side of our graph paper. I am drawing closer so that I will show you. Okay, you can see it now. Question number B says draw the graph of speed against time. Then C says use the graph to find the speed when time is 5 hours and also find the time when speed is 25 kilometers per hour. So when we get close now, we are going to go straight in plotting the graph. After I must have used this ruler that I pasted on the graph side to show you how to shoot. I promise you, I told you I'm going to use this ruler I pasted on the graph side of our graph paper to show you how to shoot scale. First of all, look at the scale that has been chosen for us to use and plot the graph. I hope you can see the scale now. It says along x-axis. This is the x-axis. The x-axis is the axis that runs from the left to the right, while y-axis is the axis that runs from bottom to the top. Okay, in the scale it says along x-axis, that means along the axis that runs from the left to the right, 2 centimeters represents 4 hours. This means, first of all, look at the calibration of our graph paper. You can see these thick lines. These thick lines are on the 4 sides of each square. The thick lines demarcates the squares. The distance from here to here is the same thing as distance from here to here, and the same thing as distance from here to here, and the same thing as distance from here to here. That means that all these things you see are squares. Then why did I put the ruler? I have put the ruler so that I will show you that the square has 2 centimeters side from this place of the ruler, from here to this place, which is the distance between one thick line and another thick line is 2 centimeters. You can see it. From here to here is 2 centimeters. That is what I want to show you with the ruler. And that was why we chose the scale that 2 centimeters along x-axis, that 2 centimeters represent 4 hours. That is going to mean that when we are to calibrate our horizontal axis, the axis that runs from the left to the right, which is the x-axis, each of the thick lines will be representing 4 hours. So if we have 0 here, for instance, we're going to have 4 here. After here we have 8, which is 4 plus 8, 4 plus 4. After here we're going to have 12, which is 8 plus 4. After here we're going to have 16, which is 12 plus 4. And it will continue like that until we get all the values we have. The same thing, the scale we chose on y-axis. We said that along y-axis that 2 cm will represent 5 kilometers per hour speed. That means each of these gaps from here to here, that is 2 centimeters, will represent 5 kilometers per hour. That means, for instance, if we have 0 here, we're going to have 5 kilometers per hour here. The next one, 5 plus 5, which is 10 kilometers. The next one, 10 plus 5, which will be 15, 20, 25, 30, 35, 40, 45 until the end. That is the meaning and how to choose scale. Let me repeat this. I said it in the formal question that we just plotted. Some graph books like this, the distance between the thick lines are just 1 cm. I only use this one that the distance between the thick lines is 2 cm for choosing that 2 cm represents the number of units that are convenient for me. Had it been that the distance from here to here has been measured and it is something from here to here, which is 1 cm, the scale could have been, instead of along x-axis 2 cm represents 4 hours, it could have been along x-axis 1 cm represents 4 hours. Likewise, along y-axis it could have been 1 cm represents 5 kilometers per hour. I hope you understand. Now we'll go ahead now to calibrate our graph paper after I remove the ruler. In calibration of your graph paper, you must consider the scale you chose and your table of values. We have chosen that 2 cm represents 4 units, 4 hours in or along x-axis. Now you are now going to look into your table of values and know the highest and the lowest number you have, so as to know how you are going to place it on your graph paper, so that you will have all the values you have in the table of value contained in the graph. Okay, like now, this is our horizontal axis, which is the x-axis. The highest number we have in the table of value is 32. Now that we chose that 2 cm represents 4 units, now let's count. If we draw the vertical line here that will mark the beginning of our calibration along the x-axis, if we have drawn the vertical line here, you're going to see that this is going to be 4, 8, 12, 16, 20, intervals of 4 hours, 24, 28, 32, which is correct. But after the 32, there's no other space. So instead of beginning from here, it's better we begin from here. Because if you begin from here now watch it. 4, 8, 12, 16, 20, 24, 28, 32. And 32 is the highest number we have on the table of value. That means drawing the vertical line is okay here. Drawing the vertical line is okay in this place. So now I am going to draw our vertical line along this thick line. When next you are going to see this graph, you are going to see the line drawn along this place. Now that I have drawn the vertical line from bottom to the up, you can see that it's now looking thicker than all other ones. Now, along the calibration we are going to have on our y-axis, which is the vertical axis that ran from up to down, you are going to discover that we already have 2 cm represent 5 kilometers per hour, and the highest value we have on speed is 40. So we are going to consider where we are going to draw the horizontal line so as to accommodate 40 kilometers per hour speed. For instance, if we draw it here, if we draw the horizontal line here and we begin to calibrate, it's going to be 5, 10, 15, 20, 25, 30, 35, 40, which is good, but it will not give any gap. So let's come down a little bit, maybe from here. We are going to draw our horizontal line here, and if we do, you are going to discover that we are going to have 5, 10, 15, 20, 25, 30, 35, 40, which is good enough. So when next you're going to see this graph paper now, you will discover that I have drawn a horizontal line on this thick line here. See that I have drawn the horizontal line. This is the horizontal line representing the x-axis, and this is the vertical line representing the y-axis. So I will now write here y-axis. Very, very important. It shows your examiner that you know what you're doing. Then on the horizontal, you write x-axis. Then at the point of intersection of the two lines, the vertical and the horizontal line, put 0. Now the next thing we're going to do now is to calibrate. First of all, let's calibrate the horizontal axis, which is the x-axis. And what we have there is time. So the time we have now, we have said that along x-axis 2 cm represents 4 units. That means from 0 to this place will be 4. Write 4 here. 4 plus 4 is 8. Write 8 on the next thick line. 8 plus 4 is 12. Write 12 here. 12 plus 4 is 16. So write 16 here. That is how to calibrate. 16 plus 4 is 20. The next thick line will be 20. 20 plus 4 is 24. The next thick line will be 24. 24 plus 4 is 28. The next thick line will be 28. 28 plus 4 is 32. The next thick line will be 32. That is it. And you can see that the highest number we have in the table of value is 32. And you have gotten 32 already. So we are done with the x-axis. Now let's calibrate the y-axis. From our scale, along y-axis, 2 cm represents 5 kilometers per hour. Begin to calibrate. From 0 here to the first thick line will be 5. So write 5 here. 5 plus 5 is 10. The next thick line will be 10. 10 plus 5 is 15. The next thick line will be 15. 15 plus 5 is 20. The next thick line will be 20. 20 plus 5 is 25. The next thick line will be 25. It will continue like that to 30, 35, and 40. And you know that the highest number we have here is 40. And that is the calibration. The next thing we're going to do now is to plot these values and draw our line. Please pay acute attention, as the line we're going to draw now is the line of inverse proportion. Unlike the former one we did, that was the line of direct proportion. 32 hours against 2.5 kilometers per hour speed. 16 hours against 5 kilometers per hour speed. 8 hours against 10 kilometers per hour speed. 4 hours against 20 kilometers per hour speed, and 2 hours against 40 kilometers per hour speed. You know that the plotting is easier than the calibration. Now we have 32. Look at 32 here. And the time, or the speed, sorry, that is attached or equivalent to 32 is 2.5. Now come to the y-axis. If from here to here is 5 kilometers per hour, that means that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small squares that made the 5. So use 10 to divide this 5. Whatever you get is the value of one small square. And if 10 to divide 5, you are going to have half, that is 0.5. That means from here to here is 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and then 5. So that means the 2.5, which we are going to plot against 32, is not going to be from 0 here, 0.5, 1, 1.5, 2, 2.5. So it's going to be here. So trace is going to be here. Trace this line to where it will meet the line of 32 along x-axis. So if you trace this line now, you can see it's this place. So after you have put your point there, you go to the next figures. The next figures is 16 as against 5. This is 16 and this is 5. So the place where the two lines join, you are going to put your point there. So our point is going to be this place. The next one is 8 hours against 10 kilometers per hour. This is 8 hours and this is 10 kilometers per hour. So the place where the two lines join is the place you are going to put your point. The next is 4 hours against 20 kilometers per hour. This is 4 hours and this is 20 kilometers per hour. So the place where they meet, this is the line where they meet. So you are going to put a point here. The last but not the least, 2 hours against 40 kilometers per hour. If from here to here is 4, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small squares. Each of the small squares is going to be 4 divided by 10. And 4 divided by 10 is 0.4. That means from here to here is 0.4, 0.8, 1.2, 1.6, 2, 2.4, 2.8, 3.2, 3.6, then 4. That means our 2, which we have from the table of value, is going to be from here to here 0.4, 0.8, 1.2, 1.6, 2. So it's going to be here. So I'm going to trace it up to where you have 40. Look at 40. You can start from here again so that it will be very, very correct. 0.4, 0.8, 1.2, 1.6, then 2. So the point is going to be this place. Now, if you look closely now, you discover that these are our points. This is the first one, this is the second one, this is the third one, this is the fourth one, this is the fifth one. If you want to join it, it's going to be a curve, not a straight line again. But the most important thing is it ran from up to down. And that shows you that the equation we have, or the relationship between speed and time, which we are about to join the curve now, is an inverse proportion. By the time when I will show you this graph paper again, I must have used my broomstick to join these points 1, 2, 3, 4, 5 in a curve. Now you can see how I am using the broomstick. This is a broomstick to join the line. What you're going to do is at a time try to join 3 points, because it will not be possible to join the whole points at the same time. 1, 2, 3, 4, 5 points. But if you can join 3 at a time, you are also going to get a perfect curve. So I'm going to join point number 1, number 2, and number 3 at once now. Just watch. So I have joined 3 points now. 1, 2, 3. Then I'm going to join 1, 2, 3 again. Watch me. It's not very easy, but that is the best way to get the curve. Some people will be using by a ruler to join point to point. It will not give you a curve. Be tracing it until you get it. Okay, now I'm going to join the remaining 3 points. My fingers are not allowing me. You can see how I did it. There are breakings here, so I'm going to join the breakings now. That's exactly how you will do it if it is in your exam hall. And if you do it so, you are going to get the whole of your marks. None will be removed. Now you can see the curve. You can see the curve. That is the curve of our graph. The next thing now is for us to begin to answer this question. We have answered question number A by constructing the table of value. Answer question number B that said we should draw the graph of speed against time. That is exactly the graph we have drawn here. Then question number 5 that said that we should use the graph to find the speed when time is 5 hours. Just go to time. When time is 5 hours, I hope you know that here is 4. And from here to here is 4 divided by 10 to get the value of these small squares. And if you use 10 to divide 4, you have 0.4. Now if you have 0.4 and they said you should calculate the speed when time is 5 hours. So 5 hours is going to be, this is 4 hours, 4.4 hours, 4.8 hours, 5.2. That means 5 hours is at the middle. I said this is 4. This is going to be 4.4, 4.8, 5.2. That means 5 is going to be at the middle of this small square, somewhere here. So we're going to trace it up. Wherever it touches, if you trace it up, wherever it touches the curve, you read the value you have. It touched the curve here. It touched the curve here. So read the value you have horizontally, the middle way here. So put a cross here and read the value. If this is 15, remember from here to here is 5. And the small squares is 5 divided by 10, which is half. So if the small square is half and this is 15, so this is 15 and a half, 16, 16 and a half, 17. That means between 16 and a half and 17, you have 16.75. So that means the answer to that one is 16.75. 0.75 kilometers per hour. That is the speed when the time taken to cover that distance is 5 hours. Now the next question says, find the time when speed is 25 kilometers per hour. When speed is 25 kilometers per hour is this place. Trace the 25 kilometers per hour, and wherever it touches your curve, trace it down. It touched the curve here, so let's trace the line down. Watch closely. So it's at this place. So we're going to read the value of that place. This is 0. Remember, from here to here is 4. And there are 10 small squares in between the 4. That means one of the small squares is 4 divided by 10. And 4 divided by 10 is 0.4. So this is 0.4, 0.8, 1.2, 1.6, 2, 2.4, and 2.8. That means the time there is 2.8 hours. 2.8 hours. So the first question, when the time is 5 hours, is 16.75 kilometers per hour, is equivalent to 5 hours, or the speed when 5 hours was taken to cover the distance. Now, when the time was 2.8 hours, we were able to have a speed of 25 kilometers per hour. 25 kilometers per hour. Now, the last thing I want to explain to you now is this. I told you that this is an inverse proportion. Number one, you can see how the curve sloped. It ran from up to down. That is a sign that this is an inverse proportion. Another thing is, if you come to the table of value, as the time decreases, the speed increases. That means as you are reducing the value of time, you are having an improvement in the value of speed. That shows that the relationship between time and speed is inverse.